In this question, we're supposed to find the particular solution for the initial value problem y prime is equal to x over y, subject to the fact that y at the point 0, x equals 0, is supposed to be equal to 3. So y at 0 is equal to 3. So this is a first order differential equation. First order because it only has a derivative of order 1, so a first derivative here of the unknown function y. And so what I'm going to do before I get started is rewrite that y prime as dy over dx is equal to x over y. And even though it's not a fraction, in this case it kind of acts like a fraction. I can pretend like this dy over dx is actually a fraction, and that allows me to multiply both sides by y, which gives me y dy, and multiply both sides by dx, which gives me x dx. And now I have all things that have to do with y on the left hand side, all things that have to do with x on the right hand side. And so now I can integrate both sides. The integral of y dy is equal to the integral of x dx. And if I anti-differentiate this y here, what I end up with is 1/2 y squared is equal to 1/2 x squared. And the constant of integration on the left hand side I'm going to combine with the constant of integration from the right hand side. I'm just going to rewrite that as plus c on the right hand side. Multiplying both sides by 2, I end up with y squared is equal to x squared plus 2c. Now many textbooks will kind of absorb that 2 into the constant. I'm going to leave it there explicitly just so you can see it. But if you do see that absorbed in a textbook, don't be worried. Now the next thing I would like to do is I would like to isolate y here, so I'd like to get y by itself. So I'm going to take the square root of both sides. This is going to be y is equal to plus or minus the square root of x squared plus 2c. Now we're kind of left with wondering, should we take the positive or the negative version of this square root? Well, if we look up here to the initial conditions, we're told that when I plug in 0 in for x, I should get the result y equals 3. If I look down here, if I plug in 0 for x, I'm going to have some stuff down here. And I should choose the positive version of the square root because the result that I'm supposed to get when I plug in 0 is positive. And the only way to get a positive out of this right-hand side is to choose the positive version of the square root. So let's go ahead and do that. Y equals the positive version of x squared plus 2c. And now what I would like to do is actually calculate what this constant is, what the c is. So y at 0, if I plug in y at 0, if I plug in x is 0 into my y, I get the square root of 0 squared plus 2c, which is equal to the square root of 2c. And I want that to be equal to 3. So I look at this and I square both sides. I get 2c is equal to 3 squared, which is equal to 9, which means c is equal to 9 over 2. So at the end of the day, the solution to my initial value problem is y of x is equal to the positive square root of x squared plus 2 times c is going to give me 9.